A warm welcome to this discussion session. We have been having these discussion sessions where I invite my teaching associates to join me and participate in the discussion, as the teaching associates essentially represent all of you who are participating in this course, and they bring before us here some of the questions that have been discussed hotly, or some of the questions which require some explanation, or some of the discussions which require more elaboration, or some other questions which they themselves have found to be important to answer. So, I am very happy to have with me today Siddhant Ranade, and Siddhant is one of my teaching associates. He has been very active. Some of you must have seen him answer some questions on the forum, and he has some very interesting points to discuss today. So, without further ado, let me ask Siddhant to put forth his points one by one for discussion.
On the discussion forums, we had a question where there was a system defined in the following way. So, where y of t was defined to be equal to x of t square u of t. So, there was a lot of discussion on this in the discussion forums, and so many of us gave actually incorrect answers or misleading answers. So, and we learned it later that we were in fact wrong. So, I would just like to ask sir to clarify it.
Yes, this was a very good question. In fact, some of my teaching associates had framed this question, and it is one of those questions which illustrate, that you can solve a problem both algebraically and graphically, and there could be advantages in one approach or the other. And what I am going to do first is to explain the meaning of this system. What does this system do? Very often in the domain of signals and systems, it is important not only to be able to write the algebra or write the algebraic description, but also to be able to interpret it properly. Interpretation is critical in many concepts in signals and systems. Otherwise, it just remains a mass of symbols. It does not really give you a meaning, and the meaning is what really gives beauty to the subject. Now, for example, here let us look at the description. It says y of t is, in fact, let me put ut first, followed by x of t squared. Now, let us forget about the ut for the moment. Suppose we took y of t, so I will call it y1t. y1t is x of t squared. Now, what does this really mean? See, it is interesting. You have to think of a mapping here. So, query any t. For example, take t equal to plus 5 and take t equal to minus 5. It would say y1 at plus 5 is x at plus 5 squared, and similarly y1 at minus 5 is also x at minus 5 squared, but which is the same. So, when you write an equation like this, so y1 at minus 5 is x at minus 5 the whole squared, which is also x at 25. So, when we write a system description like this, we must interpret it as follows. You are saying, for this t, calculate the output as follows from x, and as follows comes here. So, you pick any t and you are reading off. Of course, in this case, luckily your equation is not implicit in the sense that it is not recursive. So, then if it were recursive, then there is trouble. In fact, then you do not even know if you properly have solutions or not, but here it is very clear. The definition is clear, there is no ambiguity about the definition when I do this. So, it says at a given t, pick up the value of x at the square of that value of t. Now, what is the problem with this system? This system can only take positive values in the argument. Here, this argument can only be positive. So, it will always pick only non-negative values, is not it? Only non-negative value greater than or equal to 0 values are taken. What is the implication of that? It would mean that, for example, if I had an xt like this, only this part would ever figure in the output. the negative part of t is lost forever. Is that right? So, now let us complete the system description by multiplication by ut. Let us now bring in ut. Now, you are multiplying by ut, and ut is of course 1 for t greater than or equal to 0 and 0 for t less than 0. So, now you are saying y of t is ut times xt squared, meaning the first thing you do is whenever t is negative, yt is automatically 0 because ut is 0. And then when t is greater than or equal to 0, yt becomes essentially x of t squared, and t to t squared is an invertible mapping for t greater than or equal to 0. Is that right? You see, there is a 1-to-1 mapping. As long as t is non-negative, the mapping is 1-to-1. So, there is a point in x which corresponds to the point in y. Of course, what it does is in some sense to compress and expand, you know. So, between 0 and 1, of course, all the values between 0 and 1 get mapped between 0 and 1, and all the values beyond 1 get mapped beyond 1, and 1 is the point of transition, 1 goes to 1. But before that, there is a movement backwards, and after that there is a movement forwards. So, if you have a number greater than 1, it moves to a number, it gets pushed, So, for example, y1 of 2 is x of 4. On the other hand, y1 of half is x of 1/4. You see, it is a complicated system in that one can neither think of it as pushing things forward, nor can you think of it as pushing things back. There is a non-linear transformation on the axis there. So, the system description is unambiguous. Now, having understood, and it is easier to see this graphically, having understood the system description, one can then describe certain operations algebraically or graphically as one chooses. And now Siddhant actually has thought a lot about this example. He is going to put forward some of his thoughts now in the discussion to follow. So, Siddhant, go ahead. Tell us more about what you have understood about this system.
Suppose you give the input x1 of t equal to, let us say, t to the system, so for that input you will get the output y1 of t, which is equal to x1 of t square as per the definition of the system, which in turn is equal to t square for t greater than or equal to 0.
It is always 0 for t less than or equal to 0.
So, this will be the output for such a system. So, now suppose you define another system. So, this was the question in the forums. Suppose you say that your input is not x1 of t, but x1 of t minus 4, and you are giving this input to the system. So, the important thing about x1 of t minus 4 is how you interpret it. So, x1 of t minus 4 does not mean that the input at time t minus 4 is x1 of t minus 4. x1 of t is essentially just a function. So, x1 of t minus 4 is the value, you can treat it as the value of the function at some point. So, x1 of t minus 4 does not mean that the value of the signal at time t minus 4 is x1 of t minus 4. It actually means that the value of the signal at time t is x1 of t minus 4. So, instead of writing x1 of t minus 4, you should write it as let us say x2 of t. So, this is a much better definition for this signal. So, this is equal to t minus 4, and if you give this function as an input to the system, you will get y2 of t square. Y2 of t square is just essentially replacing t by t square in this expression here, in this expression. So, you are just replacing t with t square in this expression. So, this is t square minus 4. And just to check that things are all working fine, let us define the signal x3 of t as x2 of t plus 4. So, this is essentially just t. So, this is equal to x1 of t, and this is just to check that the system, we are not doing anything incorrectly. So this leads to the output being y3 of t square, which is replacing t by t square in x of 3 in x3, which is just t square. So you can see that, so if you do it like this, if you write x2 of t instead of writing x1 of t minus 4, you will end up with correct expressions.
Yes, that is very correct. So what Siddhant is trying to point out is that, some of, I remember, see, in this discussion there was this whole issue of whether one should meticulously go through the algebra or whether one should do it graphically. Now let me explain what Siddhant is trying to say. He is very correct in that he is saying that if I take t minus, so when he says x1, if you had x1t, let us begin with x1t again. So x1t being equal to t would lead to the corresponding output y1t given by t squared ut, so simple, So it is t squared for t greater than or equal to 0 and 0 for t less than 0. Now when you take x2t, which is described in terms of x1 as x1t minus 4, we know the interpretation. You see, replacing t by t minus 4 means you put there, see, at t equal to 4, it takes the value that the original signal took at 0. So what is that? 0 goes to 4. In other words, you are pushing the signal forward by 4 steps, and then of course everything else gets pushed by 4 steps too. So now, you have to be careful. So one way is, now I will ask you to try and attempt the same thing graphically. So how does this look? You had t would look like this. So this is x1 of t, which is essentially just a straight line passing at 45 degrees through the origin, and x1 of t minus 4 on the same graph is this, pushing the whole thing forward by 4 steps. Now what would this system do? This system would essentially take whatever is here, either in x1t for the first output or in x2t for the second output, and then make a nonlinear transformation on it. And what you need to verify now is that what Siddhant did algebraically is this done graphically, right. So you essentially, as I told you, the mapping is very clear. There is a one-to-one mapping for all points. Anyway, for t less than 0, the output is always 0. For t greater than 0, you essentially pick the point t squared from the output and put it on that value of y. So Siddhant has explained to you how to deal with the problem algebraically. You can, and as I told you in my email sent to all the participants and in the discussion too, which I recorded as a response to all of you, I said, you need the skill to also decide which might be more strategic in a given situation. So this was a very good question put up by my teaching associates, and it was one of those where you really need to decide which skill is more experienced.